All right, so I know it's been a while since you've done a lot of work with limits. I have no idea what all is like going on this screen here. I'm just trying to get this out of the way. Let's try to do that. Okay, so what I have here is the limit flowchart that I made for you. I can post this on Canvas with the review sheet, and it just basically tells you when you are given a limit to evaluate that there's really a pretty easy kind of way to go through it. So you always direct substitute first. When you direct substitute, that means that you take the number that you're given in the limit and you put it into the function. One of three things will happen. You'll get a number, any number including 0. If that happens, you're done. That's the limit. End of problem. The other thing that could happen, we're in this column right here, you get 0 over 0. If you remember, 0 over 0 is called indeterminate. What it means, though, is that there is a hole in the graph. Okay? Now here's the deal. Holes are removable discontinuities. If you get a 0 up top and a 0 in the bottom, then the factor that's causing the 0 is removable, right? Because you can cancel it from the top and bottom. So once you cancel it, right, by either factoring, multiplying by the conjugate, or getting a common denominator, once you actually remove that discontinuity, you'll be able to direct substitute again, and then you'll get a number. And so that's the limit. Now the third thing that can happen is typically the most confusing, and that third thing that can happen is you direct substitute and you get a number, so not 0 on the top, but on the bottom you get 0. That is never, ever going to give you a number, no matter what you do, okay? You're always going to keep getting 0 in the bottom. That's because the factor creating 0 is only on the bottom. If it were on top, you'd be getting 0 over 0. But since it's only on the bottom, that means that you have a vertical asymptote, which is a non-removable discontinuity, and you have to kind of check the limit from the left and right to see what infinity you're going to. All right, so I'm going to show you a couple of examples. I'm not going to do the one that's direct substitution where you just get a number because that's pretty obvious. So I'm going to pause this recording and make sure that everything's working, and I'm going to go to this other page. So give me 1 second. All right, I think we're good. I was a little bit worried that I was switching to another page and that everything I was writing wasn't showing, and that would be epically terrible. Okay, so this is actually number 14 in the review packet, and I'm going to do the limit as x approaches 1 from the left, and then the function that we have is x squared plus 2x minus 3 over x squared minus 3x plus 2. All right, so I'm going to plug in 1. So if I have 1 squared plus 2 times 1 minus 3 over 1 squared minus 3 times 1 plus 2. So let's see what we've got. We've got 1 plus 2 minus 3. That's 0 up top. And then we have 1 minus 3 plus 2, and that's actually 0 on the bottom. Okay, so we got 0 over 0, and what that means is there's a hole in the graph, and we know the hole is at x equals 1, right? Because I plugged in 1, and I got 0 over 0. So that means I'm going to be able to factor out x minus 1, because if I plug 1 into that, I get 0. I'll be able to factor out x minus 1 on the top and the bottom, and then I should be able to direct substitute again. It does not matter that this says from the left. That only matters if you get a number over 0, and then you have to figure out which infinity you're approaching. Okay, so don't worry about this being directional until you know if you have a vertical asymptote. Okay, so let's go ahead and factor this. So we've got the limit as x approaches 1 from the left, and then we'll factor the numerator and denominator. So let's go ahead and do that. Since I have a hole at 1, I already know that the numerator and denominator have an x minus 1, but if you don't think of that, you're probably okay, because you probably can factor pretty well since you're in calculus. So let's see, 2 and 1 on the bottom, as I mess it up. Okay, so let's see, middle term. So we got a positive there and a negative there. And then on the bottom, it looks like they're both negative. Okay, there it is. So we can go ahead and cancel the x minus 1s, right? And so that means that we're going to take the limit as x approaches 1 from the left. And up top, we have x plus 3, and we have x minus 2 on the bottom. And now we should be able to direct substitute again, and we should get a number. So up top, we get 4, and on the bottom, we get negative 1. And so now that's our answer. The limit as x approaches 1 from the left, and the right, actually, in this case, is negative 4. Okay? So what's happening is, as the graph approaches this x equals 1, the limit exists, but it exists at a hole in the graph. Okay, let's try one that has a vertical asymptote. All right, so this is number 15 on the review sheet. So we're going to do the limit as x approaches negative 2 of, let's see, x squared minus 2x minus 15 over x squared plus 4x plus 4. All right, so let's direct substitute. So we've got negative 2 squared minus 2 times negative 2 minus 15 over, let's see, negative 2 squared plus 4 times negative 2 plus 4. So let's see, negative 2 squared is 4 plus 4 minus 15 over 4 minus 8 plus 4. So the numerator is negative 7 and the denominator is 0. All right, so we got a number over 0. So that means there is a vertical asymptote, or what's called a non-removable discontinuity, at x equals negative 2. All right, so since it's not directional, we have to evaluate the limit from the left and the right of negative 2. And I know that my answers are going to either be infinity or negative infinity because I'm approaching a vertical asymptote. Even though factoring is not going to cause anything to cancel, it's still easier to evaluate limits with sign charts when they're factored. So you should try to factor it anyway. So let's do the limit as x approaches negative 2 from the left. And let's go ahead and write this out. So I'm going to factor it. Again, nothing's going to cancel. Well, something might cancel, but the negative 2 isn't going to be removed. So let's see up top. We've got a 5 and a 3. We have minus plus. And then on the bottom, we have 2 and 2, and they're plus plus. So to be honest, I would probably write the bottom as that squared, right? So let's see, x minus 5 times x plus 3 over x plus 2 squared. All right, so just a sign chart here. We're going to plug in a number that's a little bit more negative than negative 2. So a negative minus a negative is a negative. A number that's a little more negative than negative 2 would be negative 2.00001. If I take that and I add 3, I get a positive. The denominator is a quantity squared, so I'm always going to get a positive. So I've got a negative over a positive, and that result is a negative. So that means that the limit as x approaches negative 2 from the left of this function is actually, it's approaching negative infinity. All right, so now we have to see what's happening from the right, because we want the limit as x approaches negative 2. So we have to look from the left and the right. So same thing here. Let's just do this again. So we've got x minus 5 up top, x plus 3, and then the denominator is x plus 2 quantity squared. All right, so if I plug in a number that's not as negative as negative 2, so negative 1.9 repeating, and I subtract 5, that's still a negative. That number plus 3 is a positive, and again, the denominator is a quantity squared, so it's always positive, and that means I've got a negative over a positive, which is a negative. So from the right of negative 2, we're actually approaching negative infinity as well. So what that means is, since we're approaching the same infinity from both sides, that means that the limit as x approaches -2 from both directions is actually equal to -infinity. Okay? If you try one like number 16, so just real fast, it's the limit as x approaches 0 of x cubed minus 2 over x squared minus 2x plus 3. If you direct substitute 0 into that, you get -2 over 3. You're done. That's the limit. So sometimes direct substitution just gives you a number and you're all done. Okay, so going back to the flow chart real fast, hopefully that's working. Hopefully the screen recorder is working. If you kind of just memorize this flow chart and think your way through it, you should be good to go. Maybe, yeah.